So lecture 4 is all about food poisoning. And again, just to reiterate, there are notes downloadable that you can use alongside this course. And you will need them, especially for this section, the next section, where we look at bacterial names in detail. We look at the types of bacteria, what their growth requirements are, and questions will come up in the exam regarding specific bacteria. So just to give a little warning that it is again worth downloading the notes and using this alongside these lectures. So the aim of this unit is to provide an understanding of the causes and effects of food poisoning and to clarify the specific and generic controls required in order to prevent an outbreak of food poisoning. And the learning outcomes: by the end of this module, you will be able to identify the sources, food vehicles, incubation periods, symptoms and controls of common food poisoning organisms. Now, with all these learning outcomes, these really are the potential questions that you're going to get in the exam. So if just looking at that one, you'll need to be aware of the sources, the food vehicles, incubation periods, etc. of these common food poisoning organisms. There's only a handful, but still is a lot of information to take on board. Understand the role of management and environmental health practitioners, what we used to call environmental health officers, in outbreak investigation. And state the different type of chemicals, poisonous plants, metals and fish that can cause serious problems in the food industry. Okay, let's kick off with the causes of food poisoning. We've got bacteria or their toxins, which we covered in the previous section. We've got chemicals. These can have acute or chronic effects. Don't forget, acute is something that happens short term. Chronic could happen over a long period of time. Chronic, for example, could be a build-up of certain chemicals in human tissue that won't show any symptoms for the first few years, but after a long period of time could start showing results. Metals, poisonous plants, poisonous fish or shellfish, molds. Certain molds produce poisons called mycotoxins, myco relating to the fungal part. Bacterial food poisoning, let's have a look at a definition there. This is an acute, so short-term, disturbance of the gastrointestinal tract resulting in abdominal pain with or without diarrhea and vomiting due to the consumption of food contaminated by poisoning bacteria or their toxins. Other definitions: a causative agent is or are the bacteria, toxin or poison that contaminates the food and causes illness. The food vehicle is the food consumed that contained the causative agent. So this could well be the high-risk food that's contaminated with Staphylococcus aureus. That is the food vehicle. That gets the bacteria into the human body. So let's start off with some of the bacteria. So we get Salmonella species. Species refers to the fact there's about 2,500 different types or serotypes. And this, I'm going to mention whether it's toxic or infectious. Infectious means it's due, the food poisoning is due to the large numbers of bacteria consumed. So again, between 500,000 or 1 million more likely, which you can fit on a pinhead, will cause food poisoning. And what happens is the immune system reacts to these large number of bacteria by sending off its immune system cells to the point of entry, and the symptoms of food poisoning then are caused by our immune system. So Salmonella caused by large numbers being consumed. The incubation period is 6 to 72 hours, typically 12 to 36. Duration, 1 to 7 days. The symptoms: abdominal pain, diarrhea, vomiting, fever, and occasional deaths. There are 2,500 plus serotypes. Salmonella enteritidis and Salmonella typhimurium are the most common. It's a facultative anaerobe, so it can live with or without oxygen. And the growth range is 7 to 45 degrees C, but the optimum temperature is human body temperature, 37 degrees C. It's gram-negative, it's rod-shaped, and millions are required. Again, all the information that's on this page now, you will need to have a good understanding, because they will ask you, for example, they'll give you 4 bacteria names, and they will ask you which of these bacteria is a gram-negative rod-shaped bacterium, where the optimum temperature ranges, or the optimum temperature is 37 degrees C. Because not all bacteria will have those similar sort of results. So sources of Salmonella include raw meat, so we got raw poultry, eggs, although not so much in eggs these days, as fecal contamination and Campylobacter. Milk, meat from people, animals, rodents, and insects. The common food vehicles, how they get into food, but what food that we eat will contain Salmonella, include cooked poultry, cooked meat, raw milk, and raw egg products. Control factors: make sure that animals' feed is heat treated, is sterilised. Avoid overcrowding and transport stress. Give good segregation between animals. Hygienic slaughter of poultry and red meat. Other control factors with food: avoid raw milk and raw egg products. Thorough thawing and cooking of frozen poultry. Good personal hygiene. Exclude ill people. Detection of carriers. Good premises design and good integrated pest management. Clostridium perfringens, are again infectious, which means large numbers cause infection. Incubation period 8 to 22 hours, typically 8 to 12. Duration of illness 12 to 48 hours. Symptoms include abdominal pain, diarrhea, but vomiting is rare. So this bacteria, or these bacteria, affect the sort of bottom end of the body rather than the top end. It's anaerobic, so it does not require oxygen. It's a spore former. We looked at spores earlier. The growth range is 10 to 52 degrees C, although the optimum is 43 to 47, so quite high really for food poisoning pathogen. It's gram-positive, it's rod-shaped, and millions are required. So the sources of Clostridium perfringens include people, animals, feces, sewage, soil, dust, insects, raw meat, and raw poultry. Common food vehicles: stews, casseroles, rolled joints, and meat pies. Control factors: good separation and segregation, pre-prepared vegetables rather than raw vegetables with soil contamination, rapid cooling and refrigerated storage as soon as possible after cooking, good personal hygiene. The size of the joint should be restricted to a maximum size of about 2.25 kilograms, because we do get a lot of problems with large joint sizes and Clostridium perfringens. And excellent cleaning and disinfection. Next one is Staphylococcus aureus. This is toxic, so that means the food poisoning is caused by the toxin that comes from these bacteria, not by the large numbers that are ingested. Staphylococcus aureus is, if you like, our bacteria. It's on our body, it's on our skin, it's in our nose, our mouth, in our ears. So we've got to be careful when we prepare food. We wash our hands regularly. Don't cough or sneeze over food or near food. The incubation period is 1 to 7 hours, and there's an exotoxin produced in the food. Duration of the illness, 6 to 24 hours. Symptoms include abdominal pain, vomiting, prostration, but diarrhea is not common. So if you like, this bacteria that affect the top end of the body rather than the bottom end. It's a facultative anaerobe, so can live with or without oxygen. It's salt tolerant. Another word for that is a halophile. The growth range is 7 to 48 degrees C. The optimum temperature, 35 degrees C, so just a little under the human 37 degrees C temperature. It's gram-positive. It's a coccus shape, so it's round, it's like a globe, and it's a halophile, salt tolerant. And as I've already mentioned, the picture in the background, that is Staphylococcus aureus under a microscope, looking very much as it does like a bunch of grapes, which is where Staphylococcus gets its name from. The sources of Staphylococcus aureus include people, from the nose, mouth, skin, from spots, boils, from raw milk. Common food vehicles, milk and dairy products, desserts, custards, cooked meats, cooked poultry, and prawns. So just think of the old high-risk foods that food handlers are preparing. Control factors include good personal hygienic practices, hand washing, reducing handling of food, exclusion of staff where they've got colds, boils or septic cuts, avoiding raw milk, refrigeration of high-risk food between 1 and 4 degrees C, preferably 3 or lower, and the use of waterproof dressings, normally the blue plasters in the first instant. The blue really is to make sure it can be seen if it falls into food. But the main use of a waterproof dressing is to prevent microbiological contamination going from the cut into the food. Bacillus cereus. Again, this is another toxic one, so it produces a poison which causes the problem, not from the sheer numbers of bacteria that's ingested. This is known as the rice poisoning bacteria. If you've ever had food poisoning after eating takeaway rice or cooked rice yourself and didn't cook it properly, it could be this is the causative agent. The incubation period, there are 2 types. So again, something else to remember, just to bombard you with more information. There's type 1, which is 1 to 6 hours, and type 2, 6 to 24 hours. So there's 2 types of toxins produced. The duration of the illness, from 12 to 24 hours for type 1. Type 2, 1 to 2 days. Symptoms: type 1, abdominal pain, nausea, vomiting, and some diarrhea. Type 2, abdominal pain, nausea, diarrhea, and some vomiting. So, in effect, type 1 affects the top end of the body again, right down to the sort of small intestine or down to the stomach. Type 2 affects everything then from the lower end of the intestinal system, i.e. the small intestine down through the large intestine. So you can see there's more diarrhea in type 2 and more vomiting in type 1. It's a spore former. So as already mentioned, there are only 2 food safety bacterial families that produce spores. That's Bacilli and Clostridia. Its heat produces a heat-resistant enterotoxin. Again, you can look this up, but it's a toxin that affects the gastrointestinal tract. If you wanted to destroy this toxin, you must heat the food 126 degrees C for 90 minutes, which is nigh on impossible in an ordinary kitchen. Even you'd find that difficult in an autoclave. Growth range is 5 to 48 degrees C, but the optimum temperature is just under human body temperature again, 28 to 35 degrees C. It's gram-positive. It's a rod-shaped bacterium, and millions are required. And what it is, the millions that as they are growing, they produce a toxin. And it's the toxin that causes a problem more than the actual number of bacteria. Sources include cereals, especially rice, spices, corn flour, bean sprouts, soil, and dust. Common food vehicles include reheated rice, corn flour products, and food containing spices. Control factors: cook and serve straight away. In other words, if you're cooking any rice products, cook it and serve it hot. Hot hold above 63 degrees C, because you'll find spores won't actually germinate unless they're in the temperature danger zone, around about 37 degrees C. So when we have got rice above 63 degrees C, there's no bacteria present, but there are spores present. Cool rapidly, so it doesn't give time for the spores to germinate. Use refrigerated storage. Again, spores won't germinate in a fridge. And thorough reheating before service. Reheating to 75 degrees C is fine. Avoid cross-contamination. And have good cleaning and disinfection schedules, including clean as you go. Clostridium botulinum. So we've already covered Clostridium perfringens. This is another serotype, Clostridium botulinum. And this again produces a poison or toxin. So it's classed as toxic. Incubation period, usually 12 to 36 hours, where a neurotoxin is produced. And this is quite a serious neurotoxin. In fact, apart from pufferfish poisoning, which also produces a neurotoxin, this is probably one of the most virulent toxins known on the planet. Can kill within 2 minutes. What it does, it paralyzes the central nervous system, so any messages from the brain to other organs, for example, telling the heart to beat or the lungs to work, those messages are cut off, and so the body just closes down quite quickly. Duration: recovery may take months. Symptoms: here we go. Difficulty swallowing, slow recovery, blurred and double vision, muscle paralysis, diarrhea, then constipation, and deaths are very common. It's an obligate anaerobe, in other words, doesn't require oxygen of any shape or form. The exotoxin itself is heat sensitive, so it can be destroyed through normal cooking. It's a spore former. Growth range is 3 to 48 degrees C. It's gram-positive. It's a rod shape. And type E, Clostridium botulinum, is a psychrophile. Sources include fish intestines, soil, vegetables. Common food vehicles: low acid processed food, canned and smoked fish, bottled vegetables, honey. In fact, it aids in something called infant botulism. Honey is a very natural product. It's not heat processed or preserved in any way, shape or form, and it can contain Clostridium botulinum spores, which if you give to an infant, that's anything under 12 months, any child under 12 months, these spores can germinate within the child's stomach, the infant's stomach, because the stomach hasn't really developed any sort of acid reaction yet. So that the spores can germinate and they can release then the poison, which will result in infant botulism. This is probably why you see on containers of honey, do not feed to children under 12 months. This is the reason why. Control factors: time, temperature control. Vacuum packs, especially smoked fish, must always be kept under refrigeration. Discard any blown cans. These are cans of food that are bulging because there might be Clostridium botulinum growth within the can. The use of preservatives such as nitrates will prevent growth of Clostridium. Thorough cooking destroys the toxin. So anything above 63 degrees Celsius up to 75 will kill the toxin. Control factors, good manufacturing practice, for example, canning, bottling vegetables and fish and smoking the fish. Prevent cross-contamination, care in gutting and preparing raw fish, and prevent post-process contamination. Vibrio parahemolyticus, bit of a mouthful. Remember that word because you will impress people if you say that. It's infectious, which means it's caused by the vast numbers of bacteria that cause the immune system to react. Incubation period 2 to 96 hours, usually 12 to 18. Duration is 1 to 7 days. Symptoms include diarrhea, vomiting, fever, abdominal pain and dehydration. Again, it's the full raft of symptoms, so it affects the top and the bottom half of the body. Dehydration really is the loss of fluids because of the diarrhea and vomiting. And as I think I've already mentioned, dehydration is the killer. It's a facultative anaerobe, so it can do with or without oxygen. Growth range 8 to 44 degrees C. Optimum around about body temperature. It's gram positive, it's comma shaped, and millions are required. Sources include feces and sewage. Sewage is feces. Common food vehicles, seafood, especially prawns, or even prawns that are harvested from dirty waters or infected waters. Also things like shellfish, mussels, clams, or any other bivalves. If they grow in any contaminated water or in estuaries where the rivers come out from large cities, you will find that that's going to be heavily contaminated with sewage. One thing I don't think I've already mentioned, but in the UK and other countries throughout the world, there are sewage overflow pipes in every town or city, and when there's any storms or any floods, the sewage systems can't put up with the extra influx of water, so there's an overflow of sewage into the water supply. So it is a big problem. Not all sewage actually ends up in sewage farms. A lot of it ends up into rivers, into estuaries, and eventually into the sea. So if you are looking at putting seafood on the menu, make sure you know the provenance of the seafood, where it comes from, where it's grown, and make sure it's not anywhere near any industrialized areas. Control factors: do not consume raw shellfish. See, there's a big problem there. If you like oysters, again, you need to know the provenance of your oyster, where it comes from. Make sure it comes from clean water. Cook well. Again, that's a problem when you do sort of moule marinière or other shellfish dishes. You don't really cook them well. You're only really steaming them until the shell opens. And avoid cross-contamination. Here's another one, Yersinia enterocolytica. Again, infectious, caused by the vast numbers ingested. Incubation period, 1 to 5 days, usually 12 to 36 hours. Duration, 1 to 7 days. Symptoms include diarrhea, fever, abdominal pain, and dehydration. So this is one that affects mainly the lower half of the body. And again, dehydration from the loss of fluids because of diarrhea. Again, it's a facultative anaerobe, can do with or without oxygen. Growth range is 0 to 44 degrees C, so quite a long growth range. The optimum is 28 to 30 degrees C, so just under human body temperature. But it's not common in the UK. Sources include milk, raw pork, meat and poultry, and shellfish and fish. Common food vehicles: raw milk and dairy products, meat, poultry, fish, shellfish, especially oysters, and salads. Control factors: good hygienic practice, avoid raw fish and milk, thorough cooking, avoid cross-contamination, good time and temperature control, Effective stock rotation, especially under refrigeration. Common food vehicles, poultry, which is undercooked, cooked meat and meat products, desserts, shellfish and fish, salad, vegetables and fruit, is usually classed as viral infection, egg products and eggs, milk and milk products. And that's the last of the food poisoning bacteria, so quite a lot of information given there. As I say, use the notes that have been provided to read up on them a bit more before the exam. 10 main causal factors of food poisoning. These are the top 10, and these seem to be the top 10 every year, no matter when they're taken. The first one, number one on the hit parade, if you like, is preparation too far in advance and storage at ambient temperature. This gives rise to multiplication of bacteria within the food. Inadequate cooling, so again gives rise to multiplication. Inadequate reheating, so you get survival of bacteria. Contaminated process and canned food, so inherent contamination. Undercooking, again survival. Inadequate thawing, survival during cooking. Cross-contamination, again causing contamination. Raw food consumed, inherent contamination. Improper warm holding, where you'll get multiplication. And infected food handlers, leading to contamination of the food product and therefore food poisoning. So food poisoning management failures, there's no risk assessment on menu change, no contingency planning, poor communication between management and frontline staff, management disincentives, cost cutting on equipment, failure to recognise hazards, failure to learn from earlier errors, poor design, unrealistic demands on junior management or untrained staff, including supervisory staff, absence of routine planning and consistent procedures. So how do we prevent bacteriological food poisoning? Effective management. HACCP is a good food safety management system, which, well, must be implemented by law. Effective time and temperature control. Heat processing and cooking to the correct temperatures. Preventing contamination through looking at the food safety chain and making sure, using HACCP, that every link in the chain is sturdy and no contamination can get into the food product. Good personal hygiene practices. An effective exclusion policy. Good training, supervision and instruction. Avoiding raw foods. Using approved and reputable suppliers. Having a good, effective cleaning and disinfection management system. A good integrated pest management system. And a good waste management system. Non-bacterial food poisoning include things like chemicals. This can come from fungicides, weed killers, pesticides, cleaning chemicals and additives, etc. Metals such as antimony, cadmium, copper, iron, lead, mercury, tin, zinc, etc. Plants such as deadly nightshade, death cap fungi, daffodil bulbs, toadstools, rhubarb leaves, etc. Fish or shellfish, you can get things called scrombrotoxin coming from fish and shellfish, and something called paralytic shellfish poisoning. Molds, this has been mentioned once or twice before, comes from mycotoxins, which are the fungal toxins produced in certain foods, such as nuts, for example peanuts, and apple juice. The examples of the toxins include ochratoxin, patulin, and aflatoxin. Now, just to put your mind at rest, these are not the sort of blue-green molds that you see on bread or on cheese. These are really specialised molds that you'll only find on these certain foods under certain conditions of growth. So chemicals could be an incorrect additive, excess of additive or cleaning chemicals. Could be due to commercial greed. There's been several examples of that over the years. I remember one going back in the 80s where engine oil that had been taken out of vehicles was filtered and used as extra virgin olive oil and actually sold to the public. Quite a few people died from that. Pesticides and insecticides actually getting into the food. Packaging or leaching of certain plastic packaging. The chemicals from that packaging get into food. Poison from metals. Acid fruits should not be stored or cooked in equipment containing any of the following metals: antimony, cadmium, copper, lead, tin, iron, zinc, aluminium. That is a bit of a bummer really with aluminium, because these are the main, or this is the main metal in the catering industry we use our pots and pans made of. It's got good thermal properties, it's light, it's very robust. But really this only affects acid fruits. If you cook the acid fruits in any of these metals, you will get metallic ions, as we call them, as IONS, coming from the metal into the fruit itself. Aluminium is probably not going to hurt you, but you will get a metallic taint, and that is illegal, so you are breaking the law by doing that. Some of the other metals might give rise to chronic effects, so poison over time, such as antimony, cadmium and lead. The following metals have also caused problems in food: mercury and chromium, especially with mercury, which has been found in fish, which really inhabit coastlines around mining communities. There was a big problem, might still be a problem down in Cornwall, where tin mining used to be the one of the biggest industries, but with tin mining it does release mercury into the water. This then is taken up by the fish and it goes into their body tissues. Then it enters the food chain when we eat the fish. Dangerous plants include toadstools, belladonna, rhubarb leaves, red kidney beans, which should be boiled vigorously if they're dried for at least 15 minutes before use. Almonds contain prussic acid, which is the precursor of cyanide. And potatoes, green or sprouting, should not be used. Fish and shellfish poisoning. Different types of poison. One is called scombrotoxin. This can affect mackerel, tuna, pilchards and sardines. It's where histidine is turned to histamine and it survives the canning process. It can result from using spoilt fish. Never spoil your fish, folks. Always treat them the same as any other fish. There's a short onset of this toxic poisoning. It causes burning, rash, swelling, nausea, diarrhea and vomiting. Fish or shellfish poisoning. There's another one called paralytic shellfish poisoning. Very rare. It's where bivalves, things like mussels, clams, scallops, etc., feed on poisonous plankton. Toxin may survive cooking. There's a tingling and numbness of tongue, neck, arms and legs. The onset is 30 minutes to 12 hours. Now, we don't normally get poisonous plankton in our water unless it's what's called in the sea a red flush, or whether the weather's been extremely warm during the summer, where you get a flush of plankton that is poisonous. Another one is diuretic shellfish poisoning, or DSP. Another one is where pufferfish has been eaten and the neurotoxin that's present there has been ingested. Ciguatera, red whelk. All different types of fish and shellfish poisoning. Most of those, the top four there, are very rare in the UK. Outbreak investigation. So the aim of an outbreak investigation of food poisoning, you've got aims, objectives, you've got a food poisoning outbreak control team, environmental health practitioners are involved, there'll be a consultant in communicable disease control, CCDC, and the Health Protection Agency. These are all the things that must be put into place when there is an outbreak investigation. So the role of management during food poisoning and outbreak is to advise staff, suspend sales, remove and isolate any of the food, exclude staff, take specimens. Ill staff must be told to the investigating team who they are. Any of the foods are being implicated. What complaints have been made, what is the food history, any sampling needs to be taken as well, monitoring records, clean and disinfect, arrange for restock and answer questions. All these things is the role of management during the outbreak investigation. The sampling, for example, sampling really should be taken of your food products on a daily basis anyway, but this sometimes proves too onerous and has over the last number of years. This is why HACCP now has been introduced into food premises, so that the HACCP records should show that all reasonable precautions are being taken in order to prevent food poisoning, and it's called your due diligence. So the role of the environmental health practitioner, there are 6 key stages in the investigation. There are preliminaries, case finding, site investigation, intermediate review, source tracing and consolidation. And again, look at the notes that have been provided for more details of these 6 key stages. So, the key points for this lecture. Bacteria are the most common cause of food poisoning. We found out that. We looked at the sources, the food vehicles, incubation period, symptoms and controls of common food poisoning organisms. We looked at chemicals, metals, poisonous plants and fish and see how they can cause serious problems in the food industry. We looked at spores and toxins, found that some are heat resistant. And we looked at the role of management and EHPs in outbreak investigation. Again, just to reiterate, look at your notes for more information on outbreak investigation.